Good morning, ladies and gentlemen. Today we're going to continue talking about congruent triangles. You will be adding this to the same page that we were working on yesterday for postulates, theorems, and corollaries. Today we're going to be talking about isosceles triangles. The first one is the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite of the sides are congruent. The corollary to this isosceles triangle theorem is if a triangle is equilateral, then it is also equiangular. Equilateral, lateral is for sides, and angular is for the angles. So that means all three sides are the same, and all three angles are the same. Next is the converse of the isosceles triangle theorem. If two angles of a triangle are congruent, then the sides opposite them are also congruent. So remember, this is just working backwards, basically. If you're given that those two base angles are congruent to each other, then you are to infer that both of the sides are the same. That corollary to the converse of the isosceles triangle theorem is that if a triangle is equiangular, then it is also equilateral. So the angles and the sides go hand in hand. Again, if they're all the same angle, and therefore they'll be the same sides. All right. This goes on to your notes. I would like for you to draw the picture and write down the definition if you would like, and also this information right here. And those would be basically the only notes other than the examples that we're going to be working on. So, what is an isosceles triangle? Just to remind you, it has at least two congruent sides. So see the words at least here. We've had some interesting debates in the past about if a equilateral triangle could also be an isosceles triangle and vice versa. It's been interesting to hear some of the thoughts. Can an isosceles triangle also be an equilateral triangle? We could talk about that at some other point if you want. Let's go on to the example, finding the measure of the angle. So here we have two sides that are the same. Therefore, if these sides are the same, right, then what does that mean? That means that the angles are the same. So this would also be x degrees, not squares, x degrees. So, can we figure out what the measure of angle C is? Yes, we can. All right, so we know by the triangle sum theorem that you have all three angles should add up, right, to 180 degrees. So we know that angle A is 38 degrees. We know that angle B, sorry about that interruption. So we know that angle B is x degrees, and because the two sides are congruent, angle C must also be x. And when you add them together, it should come to 180 degrees. You end up with 2x plus 38 is equal to 180. Subtract your 38 from both sides, and you're left with 142 degrees, right? If you take that and divide it by 2, you can tell what x is. And in that case, it is 71 degrees, right? So the measure of angle C is 71 degrees. Unfortunately, I just realized that I don't actually have the graphic for number B, so let's not worry about that. Your work has been provided to you. Please pick it up from your homeroom teacher's desk once you have finished viewing the video. It is the module 23-3 classwork homework. On the front side, you're going to be telling what kind of information you have and what kind of congruent statement you can make. If there's just not enough information, then circle not enough information. On the back are 3 proofs I'd like you to try so that when I see you tomorrow, we can kind of go through and see where you're at rather than working in a team. Let's do this individually and see how much you can do. All right. Have a great one. See you guys tomorrow.